All right, so here's a quick explanation, and maybe it's not perfect, but it'll be something for you in regards to why does the graph of tangent look the way it does? Why does tangent look this way, and what are some features of it? And so when I look, at first, this doesn't make any sense to me, but then I've got to remember that, and you're going to see stuff appearing and then disappearing on the screen as I talk, but I need to go to this fact of y equals, or sorry, tangent is really sine over cosine. Okay. And so what I really want to do is I want to understand this new function, tangent, and in order to understand it, I really need to understand sine and cosine. As a matter of fact, I realize that those are numerators and denominators, and so they're going to tell me different things. And so what I want to do right now is, I want you to think about cosine. Cosine is the denominator here. So what are some significant values in a denominator? What are some numbers in this denominator, this cosine x? And why would they be significant? What would they do? And so that's what we're going to focus on right now. And so if I go to cosine of x and I just graph that, when I think about this, remember cosine is the denominator. Okay? And so when I look at this, this is the denominator. If we think about it, a denominator of a fraction, well, I mean, I suppose a denominator of 0 is a really weird thing. You know, like what happens if I divide by 0? Or in other words, at these spots where cosine equals 0, the value of the y output value, so the y value, what happens when cosine is 0? Well, we would have a denominator of 0, and so that would make, well, I can't divide by 0, that's undefined, and so we would see that tangent is undefined. And when we look at this, this makes sense because if we're looking at the purple graph, which is the graph of tangent, we're going to see that at those values, we really have these crazy asymptotes going on. Okay. So when cosine is 0, we get a 0 in the denominator of tangent, where tangent is undefined. And that makes sense. All right. So, well, is there anything else that cosine can help me explain here? I don't know. Maybe not. Maybe, I don't know. So let's go and let's look at something else. So we remember that tangent, again, is the value of sine over the value of cosine. And so what if we explore our numerator instead? What if we look at sine? So keep in mind, sine is our numerator here. So going back, if I turn on sine instead, keep in mind, the sine is our numerator. So if we're looking at this as a fraction, it's like what special values could happen up here? Well, what if sine was 0? We'd have 0 over, right? And, well, would cosine be 0 at the same spots? Would we get 0 over 0? No, we wouldn't. Because, you know, when sine is 0, cosine's at a max. I mean, if I'm thinking about, if I'm thinking about the circle, sine is maximized here and here, which is when cosine's 0, and sine is 0 here and here. Sine is 0 there, and cosine is actually at 1. So we'd end up with like 0 over 1. So when a sine is 0, right here, we end up with 0 over 1, which is 0. Oh, that's why tangent's at the value of tangent, the height there, the y value is 0. Same thing here. When sine is 0, tangent's at 0. Sine is here, tangent's 0. So we understand why those are there, and then we understand why these asymptotes are there. But why in the world why, if I'm tracking this, why is tangent going up? In order to understand that, I need to know that this x-axis for us is really our angles. And so as I'm moving to the right on my graph, my angles are actually becoming bigger, so I'm riding my Ferris wheel. And as I ride, think about what happens to the value of sine. Think about what happens to our numerator. So this is getting bigger, while the denominator, cosine, my left and right position, is getting smaller. And so if I start getting a bigger numerator with a smaller denominator, well, that means my overall fraction is going to be getting bigger. And so that's why as I ride the Ferris wheel, my tangent value is getting bigger and bigger, bigger. My y values are getting bigger and bigger and bigger. Now, how big do they get? Well, think about the denominator. We could get a really, really small denominator, right? Like we could get something like 0.01. And then, that would be like up, well, it's hard for you to see, up here, We get a 0.01, so I'm not very far over left or right. But I would be really, really high, so that would be almost 1. And if we look at that as a value of fraction, it would be really, really big, like almost 100. And that's why when we look, tangent actually goes on forever upward. Same thing happens if we start to apply, if we start to rotate the opposite way. That's really us going this way on the graph. If we look, the sine values would get bigger, the cosine values would get smaller. The only thing is sine is going to be negative now, so we're going to have a negative on the top. We're still going to have a positive number on the bottom because we're still to the right. So we're going to get big numbers, but they're going to be negative big numbers, which is why it's going down towards the negatives. So that's kind of why tangent looks the way that it does. And if we notice with tangent, you see how like I get a cycle here, and then a cycle here. If you notice, we're getting a full cycle in between two asymptotes. We're getting a full cycle between negative pi over 2 and pi. We're getting a full cycle in that span, which that tells me the period isn't 2 pi for tangent, it's pi, which is interesting. But if you think about the circle, it kind of makes sense because in the first quadrant, tangent's positive, in the second quadrant, tangent's negative, and then in the third quadrant, tangent's positive, and then in the fourth quadrant, tangent's negative. Positive, negative, positive, negative. It almost looks like I'm going through a full cycle. I'm starting to repeat myself in only half of the rotation. Now maybe you don't like this. Maybe you don't see it from sine and cosine values. Maybe you see it differently. Well, I'm going to stop this video and I'm going to have a different video for you.